Welcome back to our Dynamo Python series. In previous lessons, we covered variables, loops, list, and range already. Today, we are stepping into geometry and we will do some more advanced examples. Here, what we will do: Step 1, library imports. Step 2, mathematical operations. Step 3, scene functions and loops together. Step 4, geometry creation. And step 5, dynamic inputs. I will show in step 5 how to visualize your data with dynamic inputs. Let's start with step 1, library imports. Go to library, open our Python script, and start coding with double click. You don't have to read these boilerplates for now. Let's delete it. So there are different methods for library imports. I will show each of them. Let's start with the basic one, import math. We import math to access mathematical functions. So a library is a collection of ready-made functions. Let me show an example. A equals math dot. You can see which functions you can reach out of inside of the math library. If we use the square root one, double click, 25. Add A. So we will get 5. It was the method 1. Let's add method 1. And let me show the method 2. We import now only a specific function from the library. We will use the from math import square root function. To do that, let me show it. From math import square root. Let's say that b in this time. B equals square root of 125. So in this case, no need to write math.square root. You can directly write square root. It is the advantage of it. Let's add b. You can see the result. This one is much cleaner code. We only load that's what we need. And we have one more method, method 3. Let me show it as well. It is from math import all. If you put star, it means that in coding, you're importing each functions inside of that library. Let me show it this one as well. From math import star. Now, it is also no need to use math dot. Don't use this math dot function. Directly use whatever you want. Square root of 81, let's say that. And out C. Let's see the result. So this is the other way. It is convenient, but be careful if two libraries has the same naming functions, so they can be conflict. So step 2, mathematical operations. Python follows the standard mathematical order. Let me show one example for it. Results equals 2 times 2 plus 3 times 4. Out will be results. So of course the priority is the right side because we have multiplication of it. Let's see the result. 14. 12 plus 2, 14. We have also the accessing the mathematical constants inside of math library. Let me show it as well. Import maths and output will be the math.pi. We will the pi constant very quickly. Let's remember the range function together. Before we jump into geometry, I want to make some basic examples with range. How range, loops, and lists work together, I will show it. Let's create one empty list. List A is an empty list. So for x in range of 50, list A append x Of course, we need to go back for out, list A. As we remember, what we will do is, we made a mistake. If you see the line 59, list A append X, X is capital in here, now correct it. Okay, so we get all the list until 50. 50 is not included as we previously mentioned. Let's make it further step. So same function from math, same structure as before. We already see how the work range. Let's do this example as well. Import math, and list A will be empty list. For X in range 50, this part will be same. But in this case, instead of directly writing X, I will define Y variable as well. It will come from the math library, and I will use the sin function. We will assign X in here. Now list A dot append outside of intent, write out at list A. Let's run it. You can see how we also do see the bugs and solve them. It says 75, 19, 75. Okay, we forget the function. Now run it. Okay, in this case, we have the X written, so nothing changed, but we would like to write the Y value. So now you can see the sin function results. Step 5, let's create geometry with sin function. Now we turn those sin values into 3D points in Dynamo. Okay. For that one, we need to create a boilerplate. I will introduce a small boilerplate for it. We need to import the CLR module. It is for the common language runtime. Okay. And we also need to CLR.add reference. In the parentheses, we should write ProtoGeometry. Also, we need to import from Autodesk.design script.geometry import point, because we will use points. Also in here we use again the import function as we previously showed in math library. If I say that from Autodesk Design Geometry namespace import everything, we will get lines, circles, all those elements which we don't use, and it will crash our code. So I'm only importing the points in here. And one more, import math. So it's enough for now. Let's close the boilerplate. Let's start our coding. We have a list A again, as always, an empty list. Now I will create a for in loop for range 50, and do not forget function. Z value will be, let's say that 5 times math from sin function, and this time X. So points variables will be Point.ByCoordinates. You see again the which functions are available. Let's say that X will be the value flat for the Y value, and Z for the R variables. And of course we need that list append, list A, append points. Do not forget which variable you assign here should be as well in list append part. And output will be list A. So let's see what we created. I will make it smaller, this one, to see better this one. So it is representing the sin function waves. What we can do to see better, I will manipulate data with 0 times 2 in here. You see better the result, I guess, now. So step 6, let's make a dynamic inputs with number sliders. Okay, the boilerplate will be the same. Okay, again, I don't explain each time. Now I will make a little bit different things. Again, for x in range 50, this part will be same. Z will represent the amplitude. Amplitude times, let's say, math sin function, and we can say x time frequency. I will also define the frequency and amplitude as well. And point list, this part will be same. Point.ByCoordinates, x, no y value, and z. List a path, as always, will contain the pt values. So be careful about the capital. This should be not capital, okay? Out list A. So we assign two different variables, amplitude and frequency. So we need to define them. I will create an part in here. Let's say that amplitude will be input 0 and frequency will be equal input 1. So what we will do is number slider for those inputs. Let's increase two inputs. Input 0, duplicate, input 1. So now input 0 is representing the amplitude. We write in here. And also the other one will represent the frequency. Let's run it. You can see the result. Also, we can delete this one. Now it is much clearer. What we can do is we can increase the frequency, as you can see. Also, we can increase the amplitude, as you can see. Another good option will be we will make 10 and steps are more sensitive. Okay. You can see the result.